Hello dear friends, today we will be discussing about second order derivative. What is a second order derivative? If a function is differentiable at a point x, then its derivative is denoted by f dash and is called the first order derivative or derivative of first order of the function. And if f dash is further differentiable at the same point, then its derivative is called second order derivative or the derivative of second order of f, and it is denoted by f double dash. Say if you are having a function y is equal to f of x, its first order derivative, we can write it as dy by dx or f dash x or y1 or y dash. On the same line for the second order derivative, since it is differentiable, so we can write it as d2y by dx square or f double dash x or y2 or y double dash, or also we write it or we find it as d dx of dy by dx. Let us take some examples. Say if you are having y is equal to 3e to the power 2x, 2e to the power 3x, then we need to prove this part. So here you are having second order derivative, first order derivative and the function. Now first we will find out the first order derivative. Differentiate both the sides. For y is dy by dx. E to the power 2x is e to the power 2x, and for 2x it is 2 on the same line. 2 e to the power 3x and 3. So we are having 6 e to the power 2x plus e to the power 3x. We observe that this function is differentiable again, so we can find out its double derivative, or we can write it as d2y by dx square. So d dx of dy by dx. So we are taking the derivative of e to the power 2x. We can write same. For 2x is 2, e to the power 3x, e to the power 3x and 3. So we have been able to find out d2y by dx square. Now we'll take the equation and put the values. d2y by dx square minus 5dy by dx plus 6y. Put the values of d2y by dx square, 5, and dy by dx you have already got it, so we are taking the value here. So 5 into 6 is 30, and then 6 times of the function. So if you compute and simplify, you are finding that it is giving you 0, and which is your RHS which you wanted to prove. So you have been able to prove it. Now second question, if you are having y is equal to sine inverse x ka whole square, then we need to prove it. Now again the chain rule is very important here. So first we'll find out the first order derivative dy by dx. So outer function is square function. So this is x square, means 2x. So 2 sine inverse x. Then we have inner function as sine inverse x, in its derivative is 1 by under root 1 minus x square. So we have got this first order derivative. Now take this on this line on LHS. So you are having under root 1 minus x square dy by dx 2 sine inverse x. So from here you can directly go for second order derivative, or you can square it. Choice is yours. Both are almost the same. So here I have squared it. So squaring both the sides, this root is gone. dy by dx whole square, and this 2 square is 4, and sine inverse x ka square, and sine inverse x ka square is a y. So we can substitute it as by y. So now we have got this as 1 minus x square dy by dx ka whole square 4y. We'll be differentiating again. So here we'll be applying the product rule. So first function derivative of x square is 2x, means 2 dy by dx, and then the derivative of dy by dx, we can write this as d2y by dx square. So first function derivative of second. Now we'll write the second function. What is second function? Second function is dy by dx ka whole square, and what is first function? 1 minus x square. For 1 derivative is 0, for x square it is 2x, so it is minus of 2x, and this side on the right hand side is 4, and y derivative is dy by dx. So now you find that dy by dx is everywhere in each term, and it is not equal to 0. So we'll divide the whole equation by 2 dy by dx. 2 dy by dx. It gives you 1 minus x square d2y by dx square, because it gets cancelled. And again here x dy by dx, because 1 dy by dx and 2 will get cancelled, and this side it is 2. So that was your requirement. So you have been able to prove it. Now we'll take one more question, and very important one. If e to the power y x plus 1 is equal to x plus 1 is equal to 1. You have to show that d2y by dx square is equal to dy by dx ka whole square. Now, first, before you start, try to segregate if it can be explicitly segregated. So we find that if we just take x plus 1 this side only, e to the power y this side, so it will be dividing here, and then we can write this as e to the power minus y. So now it will be easy for us to differentiate both the side with respect to x. For x it is 1, for 1 it is 0, and for e to the power minus y is e to the power minus y, and for minus y is minus, for y it is dy by dx. So we have been able to write minus dy by dx is equal to 1 by e to the power minus y, and which can be written as e to the power y. So dy by dx is minus e to the power y. So let us consider this to be equation 1. Again we will be differentiating. So derivative of dy by dx we can write d2y by dx square. Now for e to the power y, the derivative is e to the power y, but for y it is dy by dx. So now minus e to the power y, we know that it is equal to dy by dx. So we'll use this and we can replace minus e to the power y by dy by dx. So you have been able to prove that d2y by dx square is dy by dx ka whole square. Now, and again one more important question. You are having, if y is equal to cos inverse x, find d2y by dx square in terms of y alone. So in the derivative you should be having functions of y only. So we are having y is equal to cos inverse x. So we can write this as x is equal to cos y. Now again it has been made very simple. Now we will be differentiating both the sides with respect to x. For x it is 1, for cos it is minus sin y, and for y it is dy by dx. So dy by dx can be written sin y, take it on the other side. So it will be dividing, and we can write 1 by sin is cosec y. Now further we will differentiate it. So derivative of dy by dx is d2y by dx square. For cosec, we know the derivative of cosec is minus cosec y cot y. So minus minus plus cosec y cot y, and for y it is dy by dx. Now we have the dy by dx value as minus cosec y. So that will be replacing dy by dx by minus cosec y. So you are finding it as minus cosec square y cot y, which is a function of y alone. So you have been able to find d2y by dx square. So this is how we do the questions based on double derivative. Thank you very much.